In the words of Katherine Johnson, we will always have STEM with us. Some things will drop out of the public eye and go away, but there will always be science, engineering, and mathematics, and there will always be mathematics. Now, let us define collinear points. Collinear points. Three or more points lie on the same straight line are called as collinear points. I am taking 3 points A, B and C. If 3 points A, B and C, if these are 3 are on the same line L, then we can call A, B, C are collinear points. Let us write the definition. 3 or more points lie on the same straight line. 3 or more points lie on the line. Lie on the same straight line. Are called as collinear points. If suppose if ABC are collinear, if 3 points A, B, C are collinear, then there will be 3 chances. One is case 1. If as ABC are collinear, ABC are on the same line, and there will be a chance B is in between AC. If B is in between AC, then AB plus BC is equal to AC. Length of AB and length of BC gives length of AC. AB plus case 1, AB plus BC is equal to AC if B is in between AC. Case 2. C is in between AB. If C is in between AB, then AC plus CB gives the length AB. The length of AC, length of line segment AC plus length of line segment BC gives length of the line segment AB. AC plus BC gives AB. AC plus BC is equal to AC. And the third case, if A lies in between B and C, then what happens? Length of AB plus length of AC gives length of BC. AB plus AC gives BC. AB plus AC gives BC. First of all, to know 3 points are collinear, whether the given 3 points are collinear or not, we need to find the distance between AB, BC and AC. Length of AB, length of BC and length of AC. If AC is larger than AB and BC, and if AC is equal to AB plus BC, sum of the smaller lengths is equal to length of AC, then we can say ABC are collinear. If AB is larger and if AC plus BC is equal to AB, in that case we can say ACB are collinear. If BC is larger and if BA plus AC gives length of BC, then we can say ABC are collinear and BAC are collinear and A lie between B and C. This is about collinear points. 3 or more points lie on the same straight line, then those points are called as collinear points. Here A, B, C are collinear points. If A, B, C are collinear points, can you draw a triangle as A, B, C are vertices? Let us check it out. A, B, C are collinear, so that if I draw a triangle as AB as vertices, C is not a vertex of this triangle. If I draw a triangle using through BC as vertices, but A is not vertex of this triangle. If I draw a triangle by taking AC as vertices, B is not a vertex. So if ABC are collinear, we cannot draw a triangle as all the 3 points ABC as the vertices. We cannot form a triangle as the three given points as vertices if those 3 given points are collinear. Through 3 given points, if the 3 given points are collinear, then we cannot form a triangle as those 3 given points as vertices. We know distance between 2 points A x1 y1 and B x2 y2. Distance between these 2 points A x1 y1 B x2 y2 is AB is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square units. This is the distance between 2 given points. Distance between 2 given points A x1 y1 B x2 y2 on a plane is root square x2 minus x1 whole square plus y2 minus y1 whole square units. Next one, There is a line segment AB and there is a point P which is exactly equal distant from AB. Then P is called midpoint of AB. If A coordinates of A are x1, y1, coordinates of B are x2, y2, then we can find midpoint of P by taking the average of x coordinates. We get x coordinate of the midpoint x1 plus x2 by 2. By taking average of y coordinates, we get y coordinate of the midpoint y1 plus y2 by 2. So midpoint formula x1 plus x2 by 2 and y1 plus y2 by 2. Midpoint P is equal to R pair x1 plus x2 by 2 comma y1 plus y2 by 2. Midpoint of line segment joining midpoint of line segment joining the 2 points ax1 by 1 bx2 by 2, joining the points x1 y1 comma x2 y2 is x1 plus x2 by 2 and y1 plus y2 by 2. It is the formula for finding midpoint of the given line segment. And one more, there is a line segment AB. A is with coordinates x1 y1, B with the coordinates x2 y2. There is a line L in the plane, so that line L dividing this line into two congruent parts. Then we can say this line is a bisector of this line segment AB. If a line divides the given line segment into two congruent parts, two equal parts, then the line is called bisecting line, bisector, and the point is called, the dividing point is called bisecting point. So the bisecting point formula also x1 plus x2 by 2 and y1 plus y2 by 2. The bisecting point P is equal to x1 plus x2 by 2 and y1 plus y2 by 2. Or compare x1 plus x2 by 2, y1 plus y2 by 2. Bisecting point formula, bisecting point of a line segment joining ax1 y1 bx2 y2. Is x1 plus x2 by 2, after x1 plus x2 by 2, y1 plus y2 by 2, y1 plus y2 by 2. It is the formula of the bisecting point. Distance formula root of x2 minus x square root x2 minus x1 square plus y2 minus y1 square. Midpoint formula out of x1 plus x2 by 2, y1 plus y2 by 2. Bisecting point formula x1 plus x2 by 2 and y1 plus y2 y2 as the coordinates of the bisecting point. Now let us know about the midpoint of the line segment. There is a line segment AB. M is a point on this line segment AB, so that AM is equal to MB. AM is equal to MB. Then we say M is the midpoint of AB. A, M, B are on the same straight line. Three points A, M, B are on the same straight line, so that M is equidistant from AB. M is equidistant from AB. Then M is called midpoint of AB. Point M is equidistant from AB. Then M is called midpoint of AB. Midpoint of A. Here, if we can write if A and B are on a line and AM is equal to MB, then M is midpoint of AB. Let us now get the formula for midpoint of the given line segment. If the end points of the line segments are given as the coordinates. To prove the midpoint formula as x1 plus x2 by 2 and y1 plus y2 by 2, I am taking coordinate plane. Horizontal reference line x dash x as x-axis, vertical reference line as y dash, that is y-axis. These are mutually perpendicular. Intersecting point of x-axis and y-axis as origin. Take a line segment on this plane. I'm taking a line segment AB. A as the coordinates x1, y1. Coordinates of B are x2, y2. Coordinates of B as x2 and y. Let me take M. Let me take M as midpoint of this line segment AB. That means M is equidistant from A and B. Distance from A to M, distance from B to M is same. That is, MA is equal to MB. MA is equal to MB. That is a given clue. We have A x1 y1 and B x2 y2. M is the midpoint of line segment joining AB. Next, let us take the coordinates of M. As we don't know, let me take coordinates of M as x and y. Now we need to find x and y, x value and y value. Here, let us take M as x and y. Order pair x y. And M is equal to midpoint M is equal to order pair x y. Now let us do a small construction. Here y coordinate is nothing but perpendicular distance from x axis to a point is called y coordinate. So that let me draw AP perpendicular to x axis. That is nothing but y coordinate y1, AP length is y1. And next, let us draw MQ perpendicular to x axis MQ. Perpendicular distance from x axis to a point is called y coordinate, so that it is y. MQ is y. Now let us draw a perpendicular from B onto x axis. Draw BR perpendicular to x axis. Perpendicular distance from x axis to a point is y coordinate. Here the y coordinate is y2, so that let us write BR length as y2 units. Let us write the construction. Draw AP perpendicular to x axis, that is x dash and OX. MQ perpendicular to x dash and OX, and BR perpendicular to x dash OX, x axis. BR perpendicular to x dash OX, x axis. Now let us do one more construction. I am drawing AS perpendicular to. Draw AS perpendicular to MQ and EMP perpendicular to BR. MT perpendicular to BR. Draw AS perpendicular to AS perpendicular to MQ and MT perpendicular to BR. AS and MT, two perpendiculars are drawn onto MQ and BR. So that we got two triangles AMS and MBB. These two triangles we can compare. Before that, we can observe here a rectangle. AP APQS is a rectangle. APQS is a rectangle. Why? Because angle P is 90, angle Q is 90, angle S is 90, so that angle A is 90 degree. In rectangle APQS, we know opposite sides are parallel and equal. So that as AT is y1 units, SQ also y1 units. SQ is y1 units. AT is equal to SQ is equal to y1 units. y1 units. As SQ is y1 units and MQ is y units, we can write MS. MS is nothing but MS we can write as MQ minus SQ. MQ minus SQ gives MS. MS is equal to MQ minus SQ. That is MS is equal to MS length is MQ minus SQ, that is Y minus Y1. Y minus Y1 units. So we got MS as Y minus Y1 units. MS as Y minus Y1 units. Y minus Y1 units. MS length Y minus Y1 units. Next, on the other hand, MQRT also rectangle, as we have angle R 90, angle Q is 90, angle T is 90 degree, so that here angle M is 90 in this quadrilateral MQRT. MQRT is also a rectangle. In MQRT is rectangle. Before going to that, we can observe OP. What is the OP length? Here we have x coordinate x1 for the point A. Point A we can determine by moving x1 units from origin and then vertically y1 units. To get the point A, we start from origin, move x1 units, then move vertically y1 units. So that OP length is x1. What is OQ? Here point M is xy. That means move x units from origin to the point Q, then move vertically y units, so that OQ is y x1 units, OQ is x units, OP is x1 units and OQ is x units. From this we can come to know PQ is nothing but OQ minus OP. PQ is equal to OQ minus OP. PQ is OQ minus OP, that is OQ is x units and OP is x1 units. So PQ length is x minus x1. PQ length, now we came to know there is x minus x1 units. Here in rectangle APQS, opposite sides are parallel and equal, so that PQ is equal to AS. PQ is equal to AS, therefore PQ is equal to AS. That is as PQ is x minus x1 units, AS also we have x minus x1 units. PQ is equal to S is equal to x minus x1 units. In the same manner, we can observe M, Q, R, T, also a rectangle. In rectangle, M, Q, R, T is a rectangle. So that MQ length and TR length equal, opposite sides are parallel and equal. So that here we can observe TR length is as MQ length is y units, TR length also y units. So MQ is equal to TR is equal to y units. MP is equal to MQ is equal to TR, that is equal to y units. From this, if we observe BR length is y2 units and TR length is y units, so that we can write BT length. BT length is equal to BR minus TR. BT is equal to, clearly, it is very clear, BT is equal to BR minus TR. Here, BR is y2 units and TR is y units. So, y2 BT is y2 minus y. BT is y2 minus y. y2 minus y units. So BT is equal to y2 minus y units. BT. On the other hand, here OP length is x1 units, OQ length is x units. In the same manner, if we observe what is the length of OR, if you observe the point B, coordinates of B are x2, y2. To determine the point B, we start from origin and move x2 units, then take a turn vertical, move vertically y2 units, then we reach the point B. So that OR length is x2 units, its coordinate is x2, so x2 units. As we have OQ is x units and OR as x2 units, it is very clear QR is equal to OR minus OQ. QR is equal to OR minus OQ. QR is equal to OR minus OQ. We have OR x2 and OQ x. That means x2 minus x. That is equal to x2 minus x. QR is x2 minus x units. That is x2 minus x units. It is very clear. In MQRT rectangle, QR and MT are opposite sides in a rectangle. Opposite sides in a rectangle are parallel. Opposite sides in a rectangle are parallel and equal. So that QR is equal to MT is equal to x2 minus x units. That is x2 minus x. MT is equal to QR is equal to MT is equal to x2 minus x units. Therefore QR is equal to MT is equal to x2 minus x. x2 minus x units. Now let us compare these two triangles ASM and MTB. ASM and MTB. Let us observe these two triangles. Let us compare these two triangles. Now let us compare two triangles MAS and BMT. In triangle MAS and in triangle BMT. If we observe in these two triangles, here angle S is 90 degree, angle P is 90 degree. Angle S is equal to angle P is equal to 90 degree. That means one angle is equal in these two triangles. First triangle angle S is 90, in second triangle angle P is 90 degree. And here it is very clear that MA is equal to MB. MA is equal to BM. Why? Because M is the midpoint of line segment joining AB. So that MA is equal to BM. Since it is a given M is the midpoint, that means one side is equal. One side is equal. One more. Here, if we observe AP MQ are two parallel lines. AP and MQ are parallel lines, as those are perpendicular to the same line, x-axis. Lines perpendicular to same line are parallel. So that AP and MQ are parallel, we can treat MA as transversal. Then we angle BMT and MAS are corresponding angles. So that in first triangle MAS, second triangle BMT are equal, as AP and MQ are parallel lines and MAS transversal. So that angle MAS is equal to angle MBMT. Angle MAS is equal to angle BMT. These are corresponding angles. Since corresponding angles are equal in case of parallel lines. So that one more angle is equal. Angle side angle. One angle is equal, one side is equal, and other angle is equal. By angle side angle, angle side angle, angle side and angle. By ASA comprehensive, we can say triangle MAS and MAS is congruent to triangle BMT. This is very clear. Triangle MAS is congruent to triangle BMT. Triangle MAS is congruent to triangle BMT. We know in congruent triangles corresponding parts are equal, corresponding sides are equal. By CPCP, corresponding parts of congruent triangles are equal, so that here when AS is equal to MT, AS and MT are corresponding sides. AS is equal to MT. AS is very clear. AS is equal to MT. Here AS length is x minus x1. X minus x1 units. MT length is x2 minus x units. X2 minus x units. transpose minus x to the left hand side, minus x1 to the right hand side. So x minus x will become plus x, it is equal to x2. Minus x1, if we transpose to right side, then become plus x1. X plus x to x, that is equal to x2 plus x1. Transpose 2 to the right side, that divides. X is equal to x2 plus x1 by 2. We can write it as x is equal to x1 plus x2 by 2 using commutative law. x2 plus x1 we can write as x1 plus x2. X is equal to x1 plus x2 by 2. We got the x coordinate x coordinate of the midpoint. We took it as x, that is nothing but x1 plus x2 by 2. On the other hand, MS and BT, these also corresponding sides. MS and BT, MS and BT. MS is equal to BT. Corresponding parts of congruent triangles are equal. So that we have MS length y minus y1 units, that is y minus y1 is equal to bt. Bt length is y2 minus y units, that is y2 minus y. Minus y transpose to the left side and minus y1 to the right side. So y minus y become plus y, y2 minus y1 become plus y. Here y plus y is 2y, that is equal to y2 plus y, y2 plus y1 into 2 transpose to the right side, y is equal to y2 plus y1 by 2. We can write y2 plus y1 as y1 plus y2, so that y is equal to y1 plus y2 by 2. Y is nothing but second coordinate of the midpoint M. So second coordinate of the midpoint M is y, that is nothing but y1 plus y2 by 2. So midpoint first coordinate, x coordinate we got x1 plus x2 by 2. Second coordinate is y1 plus y2 by 2. Therefore midpoint M coordinates x1 plus x2 by 2 and y1 plus y2 by 2. Midpoint M is equal to plate x1 plus x2 by 2 and y1 plus y2 by 2. For x coordinate, take the average of x coordinates of AB. For y coordinate, take average of y coordinates of AB. That gives the coordinates of the midpoint M. Midpoint of line segment joining A x1 y1 B x2 y2 is r divided x1 plus x2 by 2 y1 plus y2 by 2.